welcome to the Journey Chez Chem. Well, today are some practice warm-ups as usual, so do them to the best of your ability and I'll see you in a moment. In number 1, we are changing ice at minus 15 degrees Celsius to steam at 125 degrees Celsius. And we have to do this in steps. And the first step is a temperature change where heat is equal to mass times the change in temperature times the specific heat capacity. And we have to use a specific heat capacity based on the state that this compound is in. And the mass that we are given is 1.5 kilograms, and we need to change our kilograms to grams, and there are 1,000 grams in 1 kilogram. And if we follow our units, it will help us to determine what we need to do. And the change in temperature is 15 degrees Celsius, and the specific heat capacity of ice is 2.09 joules per gram degree Celsius, and then I'm going to change it to kilojoules. And my number comes out to be 47.0250 kilojoules for step 1. Step 2 is a phase change. And we're actually melting that ice. And so we have 6.02 kilojoules is 1 mole of water. And we have 1,500, that's what I determined from this portion here. We have 1,500 grams of ice. And there, in 1 mole of water, there are 18.0 grams of water. And then I multiply it by the 1,500 grams. And because this is multiplication, it doesn't matter what order that I go in doing this. And that comes to 501 and 6 repeating kilojoules. Step 3 is also a temperature change, and I have 1,500 grams, and the change in temperature is 100 degrees Celsius, and often that's the case in this third step. And the specific heat of water is 4.818 joules per gram degree Celsius, and 1 kilojoule is 1,000 joules. And for this number, I get 627.0000 kilojoule. It's exactly 627 kilojoules. The fourth step is a phase change, and water has a heat of vaporization of 40.7 kilojoules in 1 mole. And we have 1,500 grams of water, and 1 mole of water is 18.0 grams of water, and I get 3,391.6 repeating kilojoules. And you'll notice that heating that water from the liquid and overcoming those forces to make it gas takes an awful lot of heat, much more than any of the steps that we've done so far. The last step is again a temperature change, and we have 1,500 grams. And we're changing it 25 degrees Celsius. And the specific heat capacity of steam is 1.84 joules per gram degree Celsius. And then I change it to kilojoules. And my final number here is 69.0000 kilojoules. Now, it's very important that we write these numbers out again separately in order to add them and not make any mistakes. So I'm going to say 47.0250 and 501.6 repeating and 627.6 repeating and 3,391 and 6 this is zeros. 6 repeating here, and then we have 69.00 And I just do this to be consistent with my numbers. And these are all kilojoules. We need to always make sure that we're adding the same unit. And when I add this, I get 4,636.3582. I look back at my original problem, and all of the numbers have 3 significant digits, so my answer needs to have 3 significant digits. I look at the 6, it rounds the 3 up, and so my final answer is 4,640 kilojoules. Now that's a pretty intense problem, and it has a lot of steps, a lot of work, but we've had practice on this, and I know that you can do this. And you will need to remember the numbers for the assessment tomorrow. In number 2, we are asking for you to look at some data points, and from those data points determine which has the various characteristics. And you were given the normal boiling points. And boiling points, when they're normal, that means that it's occurring at sea level. And the one with the weakest intermolecular forces of attraction are propane, because it has the lowest boiling point, and it was negative 42.1. Then the substance with the least, that's the least volatile, would be the one that has the lowest vapor pressure, the highest boiling point, and that one would be the nicotine. And that's interesting when we think about that. The nicotine requires that much of a high temperature in order to change from the solid state all the way, or liquid, all the way into the vapor. And when tobacco is smoked, it has to go into the vapor phase. So I thought that was kind of interesting. Then the one with the highest vapor pressure would be the one with the lowest boiling point. And again, that would be propane. And that's the warm-up for today, and now you'll be going over the review worksheet with your facilitator, and that will give you an idea of what to expect on tomorrow's assessment. There will be one problem, like number 1 in the warm-up, worth 10%, and the remainder are all questions that are short answers and fill in the blanks, and they're all worth 3 points, with a couple short answer questions worth 5 points. Well, I know you'll do well, and I'm looking forward to seeing you tomorrow. Bye!